Okay, so for the first one, it says model each expression. So basically what we're doing there is 3c plus 2c is an expression because it doesn't have an equal sign. It's not something that we can solve with balancing the other end of the equation. But c is your variable. So any letter or symbol or shape is a variable. It's your unknown. So because these two numbers have like variables, they're both c, you can actually add the 3 and the 2 together and get an answer of 5c. So one way to model that is on a number line, as you can see here. So we take the 3c and we basically make 1, 2, 3 jumps, plus the 2c, then we make another 1, 2 jumps. And basically, when we look at that all together, we have 5c. So that's one way to model this. So 3c plus 2c equals 5c. And again, we can do that, we can add them together because the variables are the same, the two c's. Now, if we look at 1b, we have 3d plus 3c. Because we have a d and a c as our variables, we can't just add those together because they're not like terms. But one way to represent 3d plus 3c is through a box diagram, which you see here. You can also use the number line as we did in the first one. So for the 3d, we simply make 3d's. We're in 2 and 3, and then for the 3c, we have 3c's, 1, 2, and 3. And that represents 3d plus 3c. So you can represent them with number lines and now with box diagrams. Now for number 2 at the bottom where it says evaluate the expressions, now they're giving us the value of c and the value of d. So we plug those numbers in for the d and the c's. So to do the first one up here, we have 3c plus 2c. c equals 2 and 9/10. So we would do, remember, whenever we have a number right beside a letter, that means times or multiplication. So if c equals 2.9, so we would write that as 3 times 2.9 plus 2 times, and again, it's a c, so it's the same thing, 2.9. So once we have those two items written, all we have to do is take the 3 times the 2.9. So 3 times 2.9 gives us 8.7. Bring this plus sign down. Then we take 2 times 2.9. So we double 2.9. And we get 5.8. And from here, we simply add the two numbers together. When we add decimals, we line up the decimal point. So 8.7 plus 5.8, we line the decimal points up. We add them and bring the decimal straight down. So 8 and 7/10 plus 5 and 8/10 gives us 14 and 5/10 as our final answer, which is right here in letter A. Now for the second one, 3d plus 3c, again, if we're given the value of the variables, we plug them in. So again, the 3 is beside the variable, so therefore that means multiplication. So we would write 3 times the letter d equals 1 and 4/10 plus 3 times c, and the letter c equals 2 and 9/10. So if we multiply 3 times 1 and 4/10, we get 4 and 2/10 plus, then we take the 3 times the 2.9/10, we get 8 and 7/10. Again, we line those up on top of each other, and for standard algorithm, and we can add 4 and 2/10 plus 8 and 7/10, and we get 12 and 9/10, which you can see right over here. Okay, in this example here, this is actually a full equation. 6n plus 4 equals 16. What you see here is a pan scale. So basically solving the equation is about figuring out how many cubes must be in each of the bags, which means that we must balance the equation. or make it equal on both sides. So whatever we do to one side, we must also do to the other side in an equation. So if you take a look at this example, we have 1, 2, 3, 4, 5, 6 n. The bags represent the n, and the cubes represent the other number, the constant. So because we don't have two variables the same, we have to have two different items. So again, the bags represent the n and the cubes represent the other number. So on the left side of the scale, we have 6n plus 4 because right in the middle of the scale is the equal sign. So we're only looking at 6n plus 4. So we have 1, 2, 3, 4, 5, 6 bags, which represent 6n, and then 1, 2, 3, 4 cubes, which represent the 4. Then on the right-hand side of the scale, we have 16. So because the 16 doesn't have an n or a variable, we represent it using cubes. So there's 16 cubes on the right side of the scale. So in order to figure out how many cubes we can divide evenly into these bags, we must balance this scale out because right now it's not balanced. So to do that, we take, first of all, we have 6n plus 4 equals 16. So we can take 4 cubes away from the left side. So that would be 1, 2, 3, 4. So those cubes are gone there. And whatever we do to one side, we must do to the other to balance it out. So if we took 4 cubes over here, then we have to take 4 cubes away over here. So those top 4 cubes are gone there. So that's our first step. Now because the right side of the scale doesn't have any bags, then we can't take away bags at this point. So as of right now, what we have is we took these 4 away. So we have 1, 2, 3, 4, 5. So we now have 6n, so 6 bags on the left, equals, and then we should have 5, 10, 11, 12 cubes on the right. Now our goal is to isolate this variable or get this variable by itself. As you can see right now, it's not by itself because it has the number 6. So we know that 6 beside the n, again, that means multiplication. So in order to isolate that variable, we have to get rid of that 6. So we use the inverse operation of multiplication, which is division. And we know with fractions, fraction bars mean division. So if we want to isolate the variable, we got to get rid of the 6. So whatever we do to the left side, we also do to the right side. So we're going to divide by 6 and divide by 6. So these two cancel each other out. So then we are left with n equals, and then 12 divided by 6 equals 2. So n equals 2. So that means that there's going to be 2 cubes now in each of these bags. So if you go up here and put 2 cubes in each of these bags, that would be 2, 4, 6, 8, 10, 12, which is what we had here. So our final answer would be n equals 2. So again, equations is just about balancing. If you take some away from the left side, you got to take some away from the right side. So this is just the representing using models. Eventually we'll get to the procedural part, but right now just using models to represent. Over here on the right, I'm showing you again that we can use a number line to represent this equation. So 6n, we have the 1, 2, 3, 4, 5, 6n, plus the 4 on one side, so a big jump for the number 4. And then on the other side, we have 16. So when we put all that together, it equals 16. So again, you can show how if you take 4 cubes from one side, then you also have to take 4 cubes from this side, and you're left with 12. Then you have, again, you have your 1, 2, 3, 4, 5, 6n. So then that leaves you with 6n equals 12. And then you do the opposite of multiplication, which is division. The 6's cancel out, and you're left with n equals 12 divided by 6, which gives you 2. Another way to represent them, as I've already stated, is through the box diagrams. So 6n, so we've got the 1, 2, 3, 4, 5, 6n, plus the 4, equals the whole thing here, which is your 16. Same thing again, if I take 4 away from the top, I got to take 4 away from the bottom. I'm left with 12. So again, this shows 6n on the top equals 12 on the bottom. Then when we divide again to isolate the variable, the 6's cancel out and we're left with n equals 2. Then on the bottom, we have algebra tiles we can also use to represent them. So we have 6n, so here's our 6 n's, 1, 2, 3, 4, 5, 6 in the green, plus our 4, you notice that's all on the same side. Then we have our equal sign, then we have 16 cubes over here. And when you do this, you divide them up, so clearly you can see that n is going to equal 2. Okay, so here's another example of using different models to represent equations. So if you look at the first example here, we have 3n plus 3 equals 2n plus 10. So again, we're going to have the bags representing the n's and the cubes representing the other number, the constant. So we have 3n, so 3n on the left side plus 3, so plus the 3 cubes on the left side. Then on the right side we have 2n, so n bags represent the n, 2n plus 10, so then we have our 10 cubes on the right side. So our goal again is to balance this equation to figure out how many cubes would fit inside each bag. So if we take away 2n or 2 bags from the right, we must also take away 2n or 2 bags from the left. If we take away 3 cubes from the left, we must also take away 3 cubes from the right. And that leaves us with n on the left equals 1, 2, 3, 4, 5, 6, 7 on the right. And because n is by itself, it's isolated, we don't have to do anything else. So n equals 7, which means all we would need to do is put 7 cubes in this one bag and we would be balanced. If we go over here to the right, we have 5n plus 1 equals 3n plus 9. So again, the bag's going to represent the n's. So on the left side, we have 5n. So that would be 1, 2, 3, 4, 5 bags, plus our 1 cube, which we have here. And then on the right side of the equation, we have 3n. So that would be 3 bags, 1, 2, 3, plus 9 cubes, which we have here. Now we can start trying to isolate that variable or make our equation equal. So if we take away 3 bags from the right, we must take away 3 bags from the left. Then if we take away 1 cube here on the left, that means we have to take away 1 cube on the right. So that leaves us then with, on the left-hand side, we have 2n equals, then we should have 1, 2, 3, 4, 5, 6, 7, 8. 2n equals 8, which we have not isolated that variable. We still don't have the n by itself. So in this situation, we will do the opposite again of multiplication, which is division. So our fraction bar means division. So if we divide 2n by 2, we do the same thing to the right side, 8 divided by 2. So if we divide 2 by 2, we get 1, so that cancels out. And that leaves us with n equals, we know that 8 divided by 2 gives us 4. So n equals 4 would be our final answer there. So basically that means there would be 4 cubes in each of those 2 bags that are left. At the bottom left, again, there's another way, another equation here, 2n plus 4 equals n plus 11. So the bags represent the n. So on the left-hand side, we have 2n plus our 4 cubes equals, and then on the right-hand side of the scale, n. Anytime you have a variable by itself, that is basically saying that's one of that variable. We don't normally write it like this. We just write the variable, so the letter. So we have 1 bag for n, and then we have 11 cubes here. So to isolate that variable, to balance out our equation or our scale, we take away 1 bag from the right, we take away 1 bag from the left. If we take away 1, 2, 3, 4 cubes from the left, we must take away 4 cubes from the right. So that leaves us on the left-hand side with n equals, and on the right-hand side, 3, 6, 7 cubes. So again, that means 7 cubes in the one bag. Balances it out because there's 7 cubes here to the right, and then 7 cubes in the bag on the left. Another example on the right, 3n plus 3 equals 2n plus 10, if you wanted to show that again on a number line. So we have our 3n plus 3 on the top, so that's 1, 2, 3 jumps plus the number 3. And then on the bottom, 2n plus 10, so that's 1, 2 n's plus a big jump of 10 for our equation. And then from there, we balance it out again the same way. So if we take away 2 n's from the bottom, we take away 2 n's from the top. So that leaves us with n equals. If we take away 3 from the top, we take away 3 from the bottom, and that equals 7. So n equals 7. For the next example here, I'm just showing you again how to model using a box diagram. 2n plus 4 equals n plus 11. So on the left-hand side, we have 2n plus 4. So there's our 1, 2n plus our 4. And then on the right-hand side, we have n plus 11. So we have our n plus our 11. So again, if we want to isolate that variable to find our answer, if we take away 1 n from the bottom, we take away 1 n from the top. And that leaves us with n equals. If we take away 4 from the top, we take away 4 from the bottom. So n equals 7. Below that, we have 4n plus 1 equals 2n plus 9. So I'm showing you here how to use the algebra tiles again. So on the left-hand side, we have 4n plus 1. So there's 1, 2, 3, 4 green n's plus 1 yellow. And then on the right-hand side, we have 2n plus 9. There's 2 green n's plus 9 cubes altogether on the right. So if we were to isolate those again, if we take away 2n from the right, we take away 2n from the left. If we take away 1 from the left, we take away 1 from the right. So that leaves us with 2n over here equals 4, 8 over here. Then again, if we divide that out to isolate the variable, 2 divided by 2, it cancels out because it's 1. 8 divided by 2, n equals 4. And as you can see, this representation shows you right there, 1n equals 4 cubes. So n equals 4 would be the answer. Over here to the right, 3n plus 50 equals 2n plus 60. So we're showing you on a number line again. So the 3n plus 50 is on the top. So 1, 2, 3 jumps of n plus the big jump of 50 plus 2n plus 60 on the bottom. So 1, 2 small jumps of n and a big jump of 60 on the bottom. So again, if I want to isolate those, so I take 2 n's from the bottom, I take 2 n's from the top. So that leaves me with n equals. If I take 50 from the top, I have to take 50 from the bottom, which leaves me with 10. So n would equal 10. Same thing on the bottom with the box diagram. I have my 3n plus 50. So there's my 1, 2, 3n plus my 50. Then on the bottom, I have my 2n plus 60. There's my 1, 2n plus my 60. So if I isolate those variables, I take 2 away from the bottom, I take 2 away from the top. I'm left with n equals, I take 50 from the top, I take 50 from the bottom, and that leaves me with 10. So n equals 10. Another representation here of 4n plus 1 equals 2n plus 2. So 4n plus 1. So I've got 1, 2, 3, 4 n's plus the 1 on the top. Then on the bottom, 2n plus 9. So 1, 2n plus the big jump of 9. So to solve or evaluate that equation, again, I take 2 from the bottom, I take 2 from the top. I'm left with 2n on the top. If I take 1 from the top, then I take 1 from the bottom, that gives me 8. Then I know since I have 2 n's or 2 bags, I got to figure out how many of these 8 cubes will fit into each bag. So 2n equals 8. I divide by 2, I know n equals 4. There's going to be 4 in this n and 4 in that n. And those are the same as putting those cubes, 4 cubes in one bag and 4 cubes in the other bag. So the final answer is n equals 4. At the bottom, 5n plus 35 equals 2n plus 98. So the 5n plus 35 is on the top. There's 1, 2, 3, 4, 5 plus the 35. And then on the bottom, we have our 2n plus 98. So our 1, 2n plus the big jump of 98. So again, to isolate those, I take 2 n's from the bottom, or 2 bags away from the bottom. I do the same to the top. That gives me 3n. And if I take the 35 from the top, I have to take 35 from the bottom also. Which leaves me with 63. Then I just know that I have 63 has to be divided evenly to put cubes into each of these n's. So I know I have to divide that 63 by 3. So if I do that, the 3's cancel out because you get 1, which is simply n, equals, sorry about that. Let's erase that and go back to that again. We'll put it over here. So n equals 63 divided by 3, which gives us n equals 21. So that tells me that there's going to be 21 in this n, 21 in this n, and 21 in that n to balance my equation. And that will give me 63 on the top and 63 on the bottom. Over here to the pan scale, 4n plus 1 equals 2n plus 9. So 4n plus 1, there's my 1, 2, 3, 4 bags plus my 1 cube. And then on the opposite side, equal sign, we have 2n plus 9. So there's my 1, 2 bags for n and my 9 cubes for the 9. Okay, so I'm going to erase those so we can balance it out. All right. So if I take 2 bags from the right, or 2 n's from the right, I have to take 2 n's or 2 bags from the left. That leaves me with 2n equals, and if I take 1 cube from the left, I must take 1 cube from the right. So that means 2 n's on the left, or 2 bags. I'm left with 1, 2, 3, 4, 5, 6, 8. So my goal is to figure out how to divide 8 by 2 so I can figure out how many fits in each of these bags of n. So if I divide by 2, those cancel out. Divide by 2 again. So my n equals 4. So there'll be 4 cubes in this bag and 4 cubes in that bag, which equals 8, which equals the 8 cubes I have here. And then as you can see, our equation is now balanced. There's 8 on the left and there's 8 on the right. Algebra tiles again to model 5n plus 6 equals 2n plus 18. So here's my 1, 2, 3, 4, 5n plus my 6 cubes on the left equals 2n plus 18 on the right. So there's my 1, 2n, and then the 18 cubes on the right. So again, I can just simply see here that each n must be 4, but I can go back and take 2 from the left, 2 from the right, and take 2 from the left. Then I can take 6 cubes from the left and 6 cubes from the right, which is going to leave me then with 3n on the left equals 4, 8, 12 on the right. So then I know that I have to divide 12 by 3 to figure out how many is in each n. So I can see here that 1n is going to equal 4 just by my model, or I could do the inverse, so the 3's cancel out. Then I'm left with n equals 12 divided by 3, which is 4. And the last one I have for you here today is 12n plus 3 equals 10n plus 25. So 12n plus 3 is on the left. So as you can see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12n plus the 3 on the top. Then on the bottom, we have the 10n plus 25. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 plus the 25. So you can see the number line in there as well. Okay, so again, if I want to isolate the variable, if I'm going to take away 10 n's from the bottom, then I must take away 10 n's from the top. And if I take away 3 from the top, I must take away 3 from the bottom. Which leaves me with 22 down here. So now I know I have 2n on the top equals 22 on the bottom. I know that n is not yet by itself, it's not isolated, so I just have to take 22 divided by those 2 n's. So the 2's cancel because it gives me n, because 2 divided by 2 is 1, which is n. And then 22 divided by 2 gives me 11. So n equals 11. So if those were our bags on our pan scale, I would know I would need to put 11 cubes in each bag. And our last one here, 10n plus 32 equals 102. So with this one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the top, plus our 32, our big jump, must equal 102 on the bottom. So you can see that the last jump of the line lands at 102, so the last jump of n must land at 70. Since there are 10 jumps of n, each n must be 7 as a result. So again, another way you can do that is you simply take your, if you're going to take away your 32 from the top, then you must do the same thing to the bottom. So we take away 32 at the top, we take away 32 at the bottom, and we get 70. Now, because this side of the equation for this one doesn't have anything else with it, like the top one had a 10n plus 25 on the right, this one only has 102. So all we have to figure out is what times 10 plus 32 equals 102, and your answer to that would be then 70. Because if I take the top and I divide it and I put the 70 into all the ends, it's going to, or if I divide it, into all my ends, it's going to balance out my equation on the bottom. So that is a very quick review of what you have missed. If you've been absent, hope to see you back to school soon.